Imagine it's the 1960s in the US. It's the height of the Cold War, tensions are high everywhere, and people are looking for work. The government comes to you with an exciting opportunity. They say, work at this nuclear power plant. It doesn't require that much maintenance, and you get paid a lot. They don't tell you anything about what it's used for or the technologies in it. Sounds enticing, doesn't it? Three men thought the same, and they eventually lost their lives in the SL-1 nuclear reactor incident. Today I'm going to be talking to you about what the incident was, why it happened, ethical concerns about it, and risks overall to the population. My name is Kasia Pothula. I'm a senior at Wisconsin studying engineering, mechanics, and aerospace. So to start off, the SL-1 reactor was built in the winter of 1958 in Idaho. This was at the height of the Cold War, where the U.S. military needed to execute a plan called the Defense Early Warning System, otherwise called DEWS. This was a plan to set up several radar stations along the Arctic Circle to watch for any signs of the Soviet Union invading. And since the radar stations were in such remote areas of the Arctic Circle, there was a need for long-lasting but low-energy power stations that were able to be run with little maintenance. In order to achieve this, there was new untested technologies such as highly enriched uranium fuel, burnable poison strips to prolong operating life, and fewer control rods that were used in the nuclear reactor to have more simplicity and avoid more maintenance. So you might be wondering what actually happened, what caused this reactor to melt down, and what killed these three guys. On December 21st, 1960, the reactor was actually shut down for regular maintenance. After the maintenance procedures, the reactor was to be brought back up online, and a part of this procedure was to move the central control rod in the reactor a mere matter of inches. The safe limit for moving the control rod was about 4.2 inches, but it was actually moved about 20 inches by operator error, and as a result of that, the reactor went critical. Consequently, only 4 milliseconds later, enough heat was generated in the surrounding water to cause it to vaporize. This released an extremely concentrated amount of steam up from the reactor, causing the entire housing, which by the way weighed 26,000 pounds, to jump 9.1 feet up, and for control rods and other various pieces of assembly to be propelled upwards with a great enough force to actually become lodged into the ceiling of the nuclear power plant. The blast immediately knocked 2 technicians over, killing one and severely injuring the other. The third technician got impaled by one of the control rods and was stuck to the ceiling. It took 18 months for crews to clean up the accident site, and they were exposed to very dangerous levels of radiation. The immediate cleanup crew actually found that the one that was severely injured eventually died, and that caused the 3 fatalities. Some widespread panic ensued in the US. Something that was really trusted to be a source of renewable energy was then met with a bunch of distrust after this accident. So why exactly did this all happen? Due to the Cold War, tensions were high and experimental technologies such as a reactor with fewer control rods and things like burnable poison strips were used. Furthermore, the crew that was operating this reactor did not have a background in nuclear engineering whatsoever. They were very unqualified for it. This was an ethical concern that was because of the rushing of the nuclear reactor, using new technologies, and again, having a staff that had zero background. How are you going to have a staff manning a nuclear reactor that didn't know how nuclear reactors work? This is what caused that to happen. The SL-1 incident is considered the only fatal nuclear reactor incident in the United States. While there have been what are considered other industrial fatalities, this is the only U.S. fatality caused by the process of actually making nuclear energy. One of the long-lasting impacts of this is the design of nuclear reactors has evolved to strongly emphasize safety since then. For example, the SL-1 design, which allowed the reactor to operate with the removal of only one control rod, is not at all allowed in modern reactors.
Hello, my name is Max Attire, and today I will be discussing the ethical questions related to the SL-1 nuclear reactor. So, one question is why the reactor went critical after only one control rod was removed. And in order to answer that question, we need to look at why the reactor was designed in the first place. So the SL-1 was a prototype for a reactor that was supposed to go in radar stations and other military applications in very remote locations. And because it was going in such remote locations, the reactor needed to be built and maintained very easily. So when they were designing the reactor, the engineers decided to emphasize simplicity. And in their quest for simplicity, the engineers designed the reactor with 5 control rods, with the central control rod being able to start and stop the reaction completely on its own. Now, the issue with the central control rod having so much influence over the reaction is that if it were removed too far, it could cause the reaction to go out of control and eventually maybe lead to an explosion, which is what happened at SO1. This raises the question of why the engineers decided to emphasize simplicity over safety and whether this was the right choice. Another question is why the control rods were manually removed. So this image shows an employee manually removing a control rod at the SO1 facility. As you can see, it appears to be a pretty awkward task, and there is also no mechanisms in place to prevent the control rods from being removed too quickly. So why would the engineers design the control rod to be removed manually when they could have an automated system with a much lower risk of error? And again, the answer seems to be that they were prioritizing simplicity over safety. That a design with a manually removed control rod would be a lot more simple and have less mechanical and electrical elements than one with an automated control rod. There is one last ethical question, and it relates to control rods again. So there is a history of control rods sticking at the SO1 facility. The central control rod had been stuck 7 times, and all of the other control rods had been stuck 8 to 12 times throughout their lifetime. And it is actually possible that in the SO1 disaster, an employee was trying to remove the central control rod to a certain height, but it wasn't budging because it was stuck. So they kept struggling, and then eventually it would have slid past the point where it would lead to an out-of-control reaction, and that would have resulted in the explosion. Now, we can never know whether sticking control rods really caused the SO1 disaster, but the sticking control rods were still a huge risk, and something should have been done about it. The supervisors knew about this issue, and yet they chose to do nothing. And one last ethical question is why no one was held responsible for the disaster in the aftermath. So after the SO1 disaster, there was a formal investigation. And in these investigations, the Atomic Energy Commission, which was in charge of running the facility, repeatedly tried to shift the blame to the employees who were killed in the explosion, saying that they weren't following proper procedure, and even raising the possibility that one of the employees committed a murder-suicide. And it is our group's opinion that the engineers who designed this faulty reactor and the supervisors who knew about the sticking control rods and yet chose to do nothing about it should have been held responsible. Lessons were learned from the SO1 nuclear disaster. Most importantly, it demonstrated the importance of safety in designing nuclear reactors. Modern nuclear reactors are designed with safety as the most important factor above cost and efficiency. Additionally, we learned not to rely on only one control rod. Modern reactors have many control rods, and none of them have the ability to start and stop the reaction on their own. Lastly, mechanisms are now put in place to prevent control rods from being removed too quickly. If these mechanisms were in place on the SO1 reactor, then the disaster never would have happened in the first place.
The first risk I'm going to talk about is the social risk that poses our communities from this pulling of the pin for the SO1 reactor. Officials determined that roughly 800 people were exposed to radiation following this incident, seeing that at this time they did not know really what was happening with this reactor and if there were any issues, so they actually sent in people without the proper equipment and gear that they needed in order to not be exposed to this radiation, and also given the time period that this problem happened. In addition to that, all of the 3 men that were working in this nuclear plant actually unfortunately passed following their injuries. All of this goes into the fact that today the SO1 reactor accident is actually considered the only fatal nuclear reactor accident in the United States. While there have been what are considered, like we say, industrial fatalities at other generating stations, this is the only U.S. fatality caused by the actual process of making nuclear energy. If this accident were not to have happened, then there could have been a lot more problems. This reactor was actually in a remote area, and as you can see on the map, of all the different 47 reactors that they have, there are some that are in more dense urban areas. If we take a look at Florida specifically, these two reactors are in areas that could have a lot larger loss of life given a company not heed the warnings and lessons learned from this that were mentioned before. Moving on to the environmental risk that poses our communities from this project starts with one of the points I just made, that this was located in a remote part of Idaho, so it was not that big of an issue when something like this happened. Since it was also owned by an environmental company, the environmental agency was able to almost immediately start cleanup. It took about 18 months of cleanup, and it consisted of burying the debris about 8 to 14 feet deep below the actual site area. This actually shows, as the picture is seen, that it is almost indistinguishable from what the site would have been before it was built to where it is now. This poses a very low threat to our environment, but if other companies were not able to actually listen and take the lessons learned from this reactor, then there could be even greater significant outcomes for the environment. As we can see in our government, they do not take environmental problems lightly. They would put a lot of sanctions on this project, which could lead to a lot of greater financial risk, which I will talk about later on in the next slide. The biggest lesson learned that came out of this project was the financial and economic risk that was posed to a bunch of different companies had they not learned something from this project. The Atomic Energy Commission, which also known the National Reactor Testing Station, NRTS, had about 47 of these sites, as I mentioned before, that they immediately surveyed pending this accident. They made sure that they were operating within safe parameters and procedures and that they met specifications. What's more is that the design of the reactor actually changed following this. Before this problem, the SO1 reactor actually used the one rod design as mentioned before, and then now that is not allowed in any modern reactors today. The SO1 accident is actually known as a massive watershed point. It turned into a totally new way of doing business with reactors and enacted a new safety protocol that is now seen today. Safety manuals before this incident were about maybe a few pages and not even sometimes, but now, as we all know, with a bunch of different documents that we have to read in order to make sure we're following parameters, it is a long document, almost a whole book. Without this incident, there would be a significant reduction in profit. If companies were not to learn from this, then there would not be as much research and they would have lost a lot of economic development that they put into these projects because they would have the same issue as this SO1 reactor. It is inevitable, really, this occurrence in society if we were to accrue all the benefits that we have today. As I mentioned just now, we would not be in the same waves of energy research and other things like that if it wasn't for this project. All of these reactors had this issue, which is why they're no longer enacted today, the SO1 reactor design, and were redesigned, as I mentioned. If companies were not to follow this, then they would significantly lose all of their investments because they would no longer be able to use the product that they've created.
So, to conclude, the SO1 disaster was a horrible tragedy, but a necessary one. In the Cold War, the US was focused too much on profit and energy, and they strayed away from the most important thing, human life. The path to limitless energy is one that must be tread carefully, and the US failed to do so. Many of the rigorous safety checks and concerns surrounding nuclear reactors have their roots in this disaster. Thanks to the mistakes of our predecessors, we have now learned what precautions must be put in place to keep workers and the environment safer. Thank you so much for listening, and I would like to now open the floor to questions.